So what we're going to have here is a brief introduction about alkanes. Alkanes are a type of hydrocarbon, and as the name hydrocarbon suggests, they only consist of hydrogen and carbon joined together covalently. Alright? So alkanes are the ones where there is, if there's more than one carbon, the carbons are bound together by a single bond. So if I look down here at this one here, C2H6, the carbons are bound together by a single bond. We all know that carbon has to have 4 covalent bonds to fill its valence shell. So I'm going to put those other lines there, those other bonds. And being a hydrocarbon, I'm only allowed to use hydrogen to fill it in. This is what we call a structural formula. So in this case, ethane, which is one of the components of compressed natural gas, or CNG. We can also do what's called a condensed structural formula, where I abbreviate this as just CH3, and this is CH3. So this one here, the top one, is called a structural formula, and this one here is called a condensed structural formula. The one that I've got here, C2H6, is what we call a molecular formula. So you need to know those words when you're asked in an assessment for something. So I'll just put those up quickly. So we've got a condensed structural formula. Sorry, I thought it was back to condensed is the bottom one. That's the structural formula, so it shows all the atoms and all the covalent bonds. The one at the bottom is the condensed structural. Apologies there, my mind was going faster than my pen, or vice versa. And over on this side, we've got what are called molecular formula. All right. At the very top is what we call the general formula. All right, so the general formula. I'm hoping this fits on the screen. And there's 2 possible ones there. The little n is just a number, so it might be 1. And this is basically like an algebraic statement to say how you can predict how many hydrogens would be there. So what its molecular formula would be. So if you had 9 carbons, if it's what we call nonane, which is a really interesting one to say, then you'd have to go 2 times 9 is 18, plus 2 is 20, so it'd be C9H20. So you can use this to predict what it would be. However, alkanes aren't always that easy. Sometimes they're what we call cyclic, which is where the carbons go in a loop. So if I was to take something like hexane and make it cyclohexane, it means that the carbons go around in a hexagon. So I'll draw that, and we'll see why that's got a different molecular formula. So each carbon here is actually bound to 2 others. So each carbon can only take 2 more hydrogens. And I apologise, but for speed, I'm going to leave the hydrogens off. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogens in cyclohexane. Whereas hexane, the non-cyclic version, again leaving the hydrogens off, I'm sorry, just for speed, you'll see there it's got 14 hydrogens. So they have to have different general formulas depending on whether they are cyclic or non-cyclic. Now, we're going to get into isomers shortly. There are different ways to arrange those 6 carbons so that it's no longer hexane, but is an isomer of that. But we'll get to that later on. Okay, so general formula, molecular formula just shows you which atoms are bound in that molecule, but not how they're bound. The structural formula shows you every atom and how it's joined together, so it tells you a lot more about it. And a condensed structural formula is just a way to write that, so it gives you the same information, but doesn't take up as much paper, basically. All right? That leads me to the next thing, naming, or what we call nomenclature. And how do I get these names here? Well, the first thing is knowing that they are alkanes. So there's no other atoms in there, it's just carbon and hydrogen. And the bonding between the carbons is all single bonding, no double bonds or triple bonds, anything funny like that. Means that I know it's an alkane. So that means that all of them have the same suffix or ending to the word. They all end in ane. And again, this would be cyclohexane. So they all end in A-N-E if they're an alkane. Then you get these interesting starts, and that might help you understand some of the names that you hear branded around in the media and so on. Meth, or meth, means it's got one carbon. Meth means one. Eth, or eth, means that it's got two carbons. Prop means three. Bute, not but, bute means four. Then it becomes easy. The number is whatever shape it would be. So a five-sided object is called a pentagon, so it's pentane. A six-sided object is a hexagon, so it's hexane. A seven-sided object is called a heptagon, so C7H16 would be heptane, and so on. So they become the names of the geometrical shapes. But the first four are quite hard to remember. So I made up a little mnemonic for remembering it, to be honest, to do with a time when a certain organic compound was a bit more popular in my life, and the craving I'd had the next day. And the craving I had the next day was that I must eat peanut butter. So I'm sure you'll find one that works for you. That was my one because it actually was quite realistic. That was my craving the next day, is that I would have umpteen peanut butter sandwiches for breakfast or brunch. So, I mean, find a way to remember them because they are the hard ones. It's really common for students to get meth and eth back to front, and really common for students to get prop and bute back to front. So find a way to remember those. So that's your general introduction to alkanes. The next thing we're going to look at is isomerism.